Welcome friends in our Panasonic Robot training how to use the Teach-Pendent. This is the part 31 and today we discuss a new topic, tool offset settings. First is what is tool offset. Tool offset is the dimension surrounding the tool control point, orientation of tool to be attached to the TW flange surface of the robot such as a welding torch or gripper. The robot calculates the position of its control point, tip of the tool and the direction of the tool, the direction of travel in the tool coordinate system based on the values set up. If the tool offset is not correctly set, the robot cannot control travel speed of the tool tip or correct interpolation movement, linear weaving, etc. during operation. Improper tool offset also cause improper movement when using the tool coordinate system in manual operation. The robot can handle up to 10 tool offset values standard and switch between them as needed during operation. Note, you can change the number of tool offsets in the system data adjustment settings. Setting range 1 to 30. Next is definition of XYZ type tool offset. It uses 6 parameters XYZ, TX, TY and TZ to determine the tool offset, the position of the control point. It is determined by the parameters of x, y and z and is indicated by the flange coordinate system. See the right figure, whose origin is the TW axis rotation center on the flange surface. The direction of the tool coordinate, it is set by the parameters of Tx, Ty and Tz and is determined by rotating the x, y and z axis in the order of Tx, then Ty and Tz. You can see these figures. In this figure, you can see x-axis rotation, y-axis rotation, z-axis rotation and flange coordinate system. Now next is definition of L1 type tool offset. It uses 5 parameters L1, L2, L3, L4 and TW to determine the tool offset. When the BW axis is at minus 90 degrees, define the intersection point of RW axis and TW axis as point P, and the plane on which the control point travels by moving only the TW axis as plane Q, and define the plane perpendicular to plane Q on which the intersection point of TW rotation center and plane Q exists. L1 distance in millimeters between point P and plane Q. L2 distance in millimeters between the control point and the TW rotation center. L3 distance in millimeters between the intersection of the extension of the tool direction and the flange surface and the TW axis rotation center. L4 distance in millimeters between the control point and the plane R. TW tool settings angle in degrees measured from TW is equal to 0. Now next is setting procedure. Set the operation point of the manipulator where interpolation of the robot is controlled to move correctly. Tool name, the identifier of each tool you want to work on, up to 20 characters. L1 form, mark the checkbox to apply the L1 form to set parameters. Clear this box to apply the XYZ form. Safety holder specifies whether the robot should be in the hold state or in the servo off state when the safety holder is activated. Default, click this button to reset the tool offset values to the factory setting default. Click set standard settings, tool offset settings, tool name, tool 01, L1 form, L1 545 mm, L2 0 mm, L3 369.70 mm, L4 0 mm, TW 0 degree, safety holder servo off, default, OK, cancel. Now next is standard tool settings. It specifies the default tool to be used in new Teach programs. That is, the tool specified here will be initially displayed when you create a new program. Standard tool specifies the default tool. Click set standard settings, tool offset standard tool. Standard tool, tool 01, OK, cancel. Next is TCP, tool center point adjustment. What is TCP adjustment? Tool center point or TCP is specified by calculating the tool offset value using the specific teaching position data entered in. As the specific teaching position data for one point, teach 6 positions that are 3 positions on the XZ plane of the tool coordinate and 3 positions on the XY plane of the tool coordinate. Note, Tool mounting angle or TW value is not included in the calculation. Correct TW value of the target tool needs to be set previously. For the second point, match the TW axis center to the direction of the adjusting jig used in teaching the first point. Friends, here you can see two images of teach 3 positions. One is on XZ plane of the tool, second one is on XY plane of the tool. Please prepare a jig that can specify the position of a teaching point just like the above figures. Next one is procedure. Register TCP data. From the option list, select global variable for adjustment of TCP. Here you can see the procedure of register TCP data in this image. Edit option. Item conversion. Compensation of tool. Global variable for adjustment of TCP. Window change key switches the active cursor. Global variable for adjustment of TCP. Close. Next one is select a tool for TCP adjustment and its image is given here. Then the list of robot variables is displayed on the screen. Register the first position. You can see in this image. Align the direction of tool, wire feed direction and adjusting jig. Register a point near where the tool direction, the direction wire is fed from the welding torch and adjusting jig direction match as the first point. The first position on the XZ plane. Refer to the figure position 1 on the right. Move the cursor to an invalid robot variable and press enter key. To put a name to the registered data, enter a variable name and then click OK. Fifth is register the second position. Move the y-axis of the tool coordinate system to bring the TW center line and the adjusting jig direction parallel to each other. Then register a point near there as the second position on the XZ plane. You can see the position seconds image on right side. Position second parallelize the directions of adjusting jig and TW axis center. Number 11, tool 1, tool 01, robot TA1600, variable name TCP01, OK cancel. Note, the only Y axis of the tool coordinate system can rotate. Move the cursor to the variable you want to register the second position to and then press enter key. 6. Then move the Y axis and register the third position on the XZ plane as the fourth position. Register the same position as the first position. For the fifth and sixth positions, teach positions on the XZ plane of the tool coordinate. Note, for the fifth and sixth positions, only Z axis of the tool coordinate system can rotate. 9. R. To close the list of robot variable screen, then a dialog to confirm updating the adjustment is displayed. Make sure to save the adjustment. Second one is calculate TCP offset value. First, display the TCP adjustment dialog box if all 6 points have been registered properly. The registered variable names of the points are displayed in the P1 to P6 entry boxes. Click calculation. Third, click OK. Click set standard settings TCP adjust tool used with the calculation of TCP 1 ratio tool 01 P1 11 TCP 01 browse P4 P2 12 TCP 02 browse P3 13 TCP 03 browse P4 14 TCP 04 browse P5 15 TCP 05 browse P6 16 TPC 06 browse. OK cancel. Next one is fourth. Then a confirmation dialog box is displayed. Click OK. Check with the tool setting dialog box if the TCP offset values have been updated. So friends, here we end this part of our Panasonic robot training, and further information we will discuss in our next video.